Hello everyone. I am Krishna Kishore, professor in mechanical engineering. Today in material technology, we are going to discuss the various stages of recrystallization annealing. Now, what is the various stages of recrystallization annealing? Let me discuss the various process and the stages in annealing process. You can observe the process here, the various stages of annealing process. Here, the temperature of the material is very important in annealing process. Means during annealing stages, the temperature plays a vital role in changing the microstructure of the material. If you observe, the first stage of annealing process is recovery, the second stage is recrystallization, and the third stage is grain growth. So these are the three different stages of annealing process. Let me explain all these three stages with the help of some simple image. Observe this image here. Four images you are observing. The first image shows the cold worked material microstructure. Means all the grains you can observe, there is no formation of crystals here. There is no formation of grains also. All these are bigger grains. You can observe very clearly. So that means it is a deformed microstructure. The cold worked material means it is a deformed microstructure. You can observe the second image, the recovery stage. So that means the material undergone some temperature at a lower temperature, which is the first stage of annealing process. This is the recovery stage. In these grains are formed here. This is the recovery stage. A slow formation of grains here. Very few are formed, and the next stage is, this is after recovery. The next stage is after recrystallization. So that means complete recrystallization. All crystals are formed here. All new crystals are formed here. This is called as a recrystallization process. And when compared to recovery, recrystallization temperature is more. And the last stage is grain growth. So this is the final stage of annealing process. The first stage is recovery. The next stage is recrystallization. The next stage is grain growth. So these are the three various stages of annealing process. Let me explain the first stage, that is recovery. So what is recovery here? Observe the definition first. Recovery is a process by which deformed grains can reduce their stored energy by the removal or rearrangement of defects in their crystal structure. Here the main intention of recovery is to reduce the strains, whatever the stress or strains happen or induced in the material. We have to remove those strains, and by rearrangement, by rearranging all those defects, this recovery is formed. This is the first stage in annealing process. The main salient feature of recovery is this occurs at a lower temperature. So that means a small temperature is needed to do this process, that is recovery process. And when compared to other recrystallization or grain growth, the recovery process observed before new strain-free grains are formed. So that means this sentence clearly shows that this recovery, whatever the grains formed due to this recovery, are not strain-free grains. You can observe the image here. This is how the recovered structure is appeared. This is the fine grained microstructure. It is converted to coarse grained microstructure after recovery process is completed. And what is the main difference between recovery and recrystallization? First of all, observe the recovery here. So here the recovery observed at low temperature. That means a low temperature annealing heat treatment. So means recovery is a annealing process, which is the heat treatment process observed at low temperature, and the main purpose is to eliminate residual stresses during deformation. The main salient feature of recovery is it is not supposed to reduce the strength of the cold worked material when it is happening on the material. So that means during recovery, there is no reduction of strength of material. So this is the main feature of recovery. And recrystallization, here the temperature when compared to recovery, the temperature of the recrystallization is more, and above which the effects of strain hardening, whatever the strain hardening effects are observed in the material, all they are eliminated during annealing. So this is the main feature of recrystallization. You can observe with the help of some simple figure. You can observe the various stages in annealing process. This is the first microstructure. This is the deformed microstructure that is in cold worked material. This is the first stage at room temperature. After that, recovery stage, a small forms, that means at least some few number of grains are recovered in this recovery stage, which is happened at a lower temperature. After this recovery stage is completed, then the nucleation is going to form. So that means the small grains are going to form. That is called as a recrystallization nucleation. So that means a partial recrystallization. This is called as a partial recrystallization. After some time, the complete material is like this. That means full recrystallization. So which can be represented as a full recrystallization process. The complete recrystallization process is observed on the surface of the material. Now, if the annealing process is continued, then this is the final stage of annealing process. That means the grains, whatever the grains formed in recrystallization process, they are grow like this. That means a bigger grains are formed like this. That is observed as a grain growth. And you can observe the recrystallization. So let me explain. So what is a recrystallization? Now you have seen the various pictures here. Let me explain the salient feature. The main feature under recrystallization is the dislocation decreases only a little during recovery, and the deformed grain structure is largely unaffected by recovery. This sentence clearly shows why recrystallization is required. If already recovery is reducing the stresses, but recrystallization is needed for every material. Why? Because this recovery reduces only the little deformation. So that's why this recrystallization is needed. And you can observe the last sentence here: deformed grain structure is largely unaffected by the recovery. So that's why recrystallization is needed. And the recrystallization, the main feature of recrystallization is it takes the nucleation, starting of the grains, and growth of new grains to initiate much larger change. So that means which is usually represented as a recrystallization. So this is happened in the material. So that's why recrystallization is compulsory for any material after recovery process is completed. Then one more feature, the main feature, finer grain size. So that means if the size of the grain here plays a vital role here, finer grain size depends most on the degree of deformation. How much deformation is happened on the material. So it depends on that, grain size depends, and to lesser extent on the annealing temperature. So this is the main feature, and this is important feature of the recrystallization. The greater the deformation and lower the annealing temperature. So that means if the deformation is more, automatically the temperature, whatever the temperature that is used to deform the material will be very, very less. That means annealing temperature is very, very less. The smaller the recrystallization or recrystallized grain size. So size here plays a vital role in changing the material properties. Now you can observe what is the grain growth exactly. after recovery and recrystallization process are observed on the material, is grain growth is necessary. Observe the sentence, then you can understand why grain growth is needed. In material science, grain growth is the increase in size of grains in a materials at high temperature. So it clearly saying that at high temperature we are doing this process, that is grain growth process. If the high temperature is used for the material, automatically it leads to the failure. But why this grain growth is observed on the material? You can observe this sentence. This occurs, that means grain growth occurs when recovery and recrystallization are complete and further reduction in the internal energy could only be achieved. So that means even after recovery and recrystallizations are observed on the material, but if they are unable to reduce the internal energy or the stresses, then the grain growth is the only process which is used to reduce whatever the internal stresses and all other defects which are existed in the material. So that's why grain growth is the last stage in annealing process, which is achieved by reducing the total area of grain boundary. You can see the various images. This is the deformed state. This is the first state, that is the cold work state. This is the recovered state, and this is the nucleation starting state. You can observe the various nucleations, small nucleations and big nucleations started. Partially, we can say that partially recrystallized state. This is the complete recrystallized state here. After this, if you increase the temperature, this is the final stage of annealing process, that is a continuous grain growth. Grains are increased like this. Sometimes if you increase the temperature further, sometimes a discontinuous grain growth may be happened in the material, which is again another defect. So that's why you have to stop at this microstructure. You can observe the various salient features here. Why or what are the major advantages of grain growth? You can see the major advantage is it prevents narrow sizes and intergranular and grain boundary corrosion or increases. So these are the three advantages due to grain growth. So that's why we are applying grain growth. Here we are utilizing nucleation word in grain growth. What is the nucleation here? If you observe the sentence, nucleation is a process in which small clusters of atoms arrange themselves in a melt when being cooled and result in formation of new grain. So that means nucleation is the initial stage in which the annealing temperature is very, very high. So after nucleation is completed, then automatically grains increase their size. So that means when the growth of such grains takes place, it is known as grain growth. You can observe the same image here. Recovery, after that recrystallization, then grain growth. Here, the main point is why this grain growth is undesirable, even though the grain growth is giving a lot of advantages and a lot of applications. Why this is undesirable for any material? Here, the main problem with the grain growth is it is usually undesirable because it requires high temperature. This is the main disadvantage of grain growth. If you are utilizing high temperature may lead to failure. This is the main disadvantage of grain growth. So that's why grain growth to occur, the process of recovery and recrystallization must take place simultaneously. So to avoid failures, the recovery, the first stage and the second stage, that is the recrystallization process, must be done simultaneously. Here we are saying the word grain size. What affects the grain size? Here, whether the grain size is important or not, yes, the grain size is very, very important, which affects the material properties. Smaller grain size have greater ratios of surface area to volume, which means a greater ratio of grain boundary to dislocation. Here, the dislocation moment is very, very important in changing the material properties. So that's why we are concentrating on grain size here. If these smaller grains have a greater ratio of surface area to volume, so that's why grain size plays a vital role in changing the material properties. The more grain boundaries that exist, the higher the strength becomes. So that's why we are concentrating on increasing the number of grains in the last stage of annealing process, that is grain growth. So that's why grain growth is the main stage in annealing process. So this is all about recrystallization annealing process, the various stages, that is recovery, recrystallization and grain growth. So this is all about annealing process. I am Krishna Kishore. In next coming videos, we will discuss some more points. Thank you one and all. This is Krishna Kishore signing off. Thank you.